Oh, that's cool.
Hello everyone, and hello to my massive class here in the room. So you're not missing out, we're going to carry on, and actually we're going to start something new today. So today our objective, if you write it on your bits of paper, we're going to be talking about simplifying algebraic fractions.
What's the date? 16th?
And the date today, well, we in class are doing this on the 16th. Because I have to edit this, it probably won't come out until later this afternoon. So you may find you're doing this early next week, I don't know. So we can simplify fractions, and algebraic fractions are just, as the name suggests, fractions with algebra involved. So go on, just to warm up, can I get you to simplify these three fractions for me? So I won't pause the video at this point, but I'll give you a couple of minutes just to try those. So you might want to fast forward if you're pretty good at it and you do it quickly.
I got the first one.
Were there printouts? There were a stack of printouts. Where are the printouts gone? Oh, there. So. So go on then, Katie. First one.
2/3.
Very good. Top and bottom by 3. Zach, any joy with the second one? 5/9. Very good. Divided top and bottom by 9. You can divide by 3 and then divide by 3 again, but of course with simplifying fractions you've got to make sure you divide as far as you can, and that's no different with algebraic fractions. And Tom, what we're going to divide by in the last one? But if you look at these two numbers, what times table do I know they're both in? Both in the 5 times table. That's a good start, isn't it? So I know 100 is 20 times 5, and that's 5 times 5, so that's 25 5s. And so 100 is 25, so 200 will be 45, so that's 44. And can I go any further?
No.
I cannot, so we're okay with that.
Is that so the door?
That's just somewhere out in the corridor. Now the word simplifying is the word we're probably used to use, but sometimes the word cancelling is also used. So the two things they mean the same thing. So simplifying, cancelling, it's the same thing. So let's look at 4 examples of fractions that involve algebra, and we're going to do the same thing. We're going to simplify them. Okay. So we've got this example here. I've got this example here. Trying to avoid this area where I think there's a big reflection, so I'll come down to here. And then lastly, I'll come here. So with all of these, I don't know if you can hear that rather spooky, creaky noise on the video, but something's going on in the corridor. So all of these can be simplified, and they're all algebraic fractions because as well as numbers, they've got algebra. So just like we asked the same thing, asked here, what can I divide both numbers by? I do the same thing here. So Katie, what can I divide 4 and 8 by?
4.
Both in the 4 times table. So that would give me a half, wouldn't it? A half. If you cancelled 4/8 down, the fact I've got an x and a y there as well doesn't change it. So I'm left with 1x, which I'm just going to write, and 2y. So sometimes with algebraic fractions, you can divide both by a number. So Zach, what have top and bottom, numerator and denominator, got in common here? There's no number this time, but what do they have in common?
X's.
Both got an x, yeah. And we did this the other day in one of those revision questions, yeah. So I can't simplify the numbers at all, 16 and 3, I think I can divide them both by. But I can divide x by x. If you do x divided by x, you just get 1. And so that would leave me with 16 times 1 over 3, which is just going to be 16 over 3. So this sort of cancelling out is an approach that we use regularly with algebraic fractions. And so that's why I often find I use the word cancelling. That sort of, I'm just saying, yeah, that gets cancelled out by that. So Amy, what about down here? What number have these two got in common? What can I divide them both by?
Divide them both by 4.
Right, so 8 divided by... Brilliant, you've done both, yeah. So 8 divided by 4 is 2, 4 divided by 4 is 1, but you're right, they've both got an x, and x divided by x is 1, so I can just cross them out. So what I'm left with is 2y's, and on the bottom, 1. So actually that's not a fraction at all, is it? 2y over 1 is just 2y. And then this one here, well, do you know what? I'm going to rewrite that one. I'm going to rewrite it over here so that we can sort of see exactly what it's made up with. Now you probably won't feel you need to do this step, so I'm rewriting this one over here. I'm writing it like this, because I'm about to write what I've wrote. So I've got 3x squared, so that's x times y, over 9x cubed, so that's x times x times x, y squared. And if you get one like that, writing it like this means you can't fail to get it right. I know firstly with the numbers that I can divide them both by 3. Here I've got x divided by x, which I know just gives me 1, so I cancel those two x's out. I've got another pair though, look, x divided by x. Can't cancel that one out because I haven't got a corresponding one above, but I've got a y here that can cancel out with that y. So I'm left with, on the top, just 1. And on the bottom I've got 3xy. Now could I have done that straight from here? Well, some people can, and you know, I don't mind whether you want to write it out longhand or like this. We could do the numbers like this, that's 1 and 3. X squared and x cubed, well you could say, well those two x's are going to cancel out 2 of those 3 x's, so they'll just be left with 1. And that 1y cancels out 1 of the 2 y's, so I'm just left with 1y. So you could choose to do it like that, but if you're not sure, do it like that, because you can't fail to get it right if you do it like that. Okay, so on the email I sent you, and on class charts, actually no, I haven't used email, I'm using class charts, sorry. On class charts I've attached a PDF. Open up your PDF and you'll find some questions on there. No peeking at the second page, because that's the answers, but can you have a go at question 1 on that PDF? Pause the video and come back when you've had a go at question 1. GoPro stop recording. GoPro stop recording. Okay, so here I can't do anything with the numbers, but that x cancels out 1 of those, so I'm just left with 2 over x. Here the numbers both in the 7 times table, and those 3 x's cancel out 3 of those, so I'm just left with 1x, so we're left with 7 over 2x. Write it out longhand if you'd rather, if you can't see that. I have written a C out longhand, so I've got both can be divided by 5, and then that s cancels out that s, so I'm left with 5s squared t over 1, so it's just 5s squared t. And here, a's can't cancel. The numbers, that's actually 1 and 2. 52 is 2 times 26. A's don't cancel. Those 3 b's cancel out those 3 b's, and those. So it's a bit weird and abstract, but it's quite satisfying sometimes just to get rid of it. So I've got a squared c cubed on the top, and 2b squared on the bottom. Okay, right, let's move on then. So sometimes we get algebraic fractions where you've got more than one thing either in the numerator or the denominator, more than one term. And it's important that when we're faced with that and we're simplifying that we do it properly. So let's look at some examples of that. So I'm going to do 2 examples. So we've got 14x squared. Actually, no, I've got 3 examples, sorry. Right. So the important thing to remember when you are simplifying fractions is when I simplify a fraction, going back to 6 over 9, I divided the top and the bottom by 3. And I can do the same thing here. I can divide the top and the bottom by something, provided all of the terms can be divided. So I can't just divide this by x, but not that by x. So I've got 3 terms here. I can only simplify if they can all be divided by something. So here, what have all 3 terms got in common?
X.
They've all got an x. So I can divide them by an x. I can't cancel out those 2 x's with 3 of those because I haven't got the same number here. So I can only simplify if I can divide everything. So I'm going to divide everything by x. So 3x just becomes 3. X squared, which is xx, just becomes x. And x cubed becomes x squared. So I'm left with 14x over 3 minus x squared. So I've divided everything by x. So here, no simplifying allowed. Can't simplify it. I've got 4 terms. Simplifying. Got 4 terms, and 3 of them have got an x, but 1 of them hasn't. So I can't divide by x. 2 of them have got a 2, but I can't divide by 2 because I haven't got a 2 there. So I can't simplify that. You mustn't think I can cancel out an x here and here. No, when we're adding terms in algebraic fractions or subtracting as here, you can only cancel if you can divide everything. So, Zach, sorry. What about this last one? Talk about numbers first.
So they're all in 2 times table.
So I'm going to divide them all by 2. Right, so I've got a 4, 2, 1 and 5. Tom, tell me about letters. I've got 4 terms here in this algebraic fraction. Do they have any letters in common? They all have an x. This one's got x squared, this one's got x cubed, but this one's only got 1x, this one's only got 1x. So I can only cancel 1x. So I cancel 1x from each term. So there it goes, there it goes. This therefore becomes just x on its own, it was x squared, and x cubed becomes x squared. So it looks a bit of a mess, so let's rewrite it. I've got 4y plus 2x over 1 plus 5x squared. Can't do any more simplifying, even though I've got x's here and here, even though I can divide, I can't do any simplifying. So, on your questions, have a go at question 2 and question 3. And pause the video and come back when you've done that. GoPro stop recording. Okay, so hopefully for the first one you just cancelled out the x's, so 1 there, and 1 of the 2 there, so you're just left with 7 over 5 minus x. Here the only thing you could divide by was 2. Looks like it should have been more than that, but no, it's just 2, so that's 4, and that's 24, and that's 3, and then they've each got a t, so there's that t, one of those 2 t's, and that t, so again it looks a bit of a mess, but you've got 24 minus 3t over 4s squared. No numbers here at all, but they've all got a c, 1 there, and one of those 2, so you've got 3d and 8 plus 6c. Here you can't touch the letters at all because there's no letters in common, but you can divide everything by 4, so that becomes a 3, that becomes a 1, which I'm not going to bother writing, and that becomes a 2, algebra unchanged. Here, divide by 4, so that disappears, becomes a 1, I'm not going to bother writing it. 2, 2, and 4. And then it looks like I can cancel S's, but no, there's no S here. And it looks like I can cancel T's, but there's no T here. So actually, I've gone as far as I can. So I've got ST plus 2S squared and 2T squared plus 4ST. It looks like surely there must be more cancelling to be done there, but no, there isn't. 5s, so that's 3, 3, 5, and 5. And the only letter in common is Z, so I've got Z, 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 and Z. So that gives me 3x plus 3 over xy minus 5y. Excuse me. And here I can divide by 3 and nothing else. Looks like I should be able to cancel letters, but no, they haven't got a letter in common. So that's, oh, that's 1, sorry. So when I cancel out that 3, it just becomes 1y, so I don't bother writing the 1. But of course here I do need to write the 1 because there's no algebra there. And then here, no numbers, but I can divide by an A. There's an A there, and one of those two A's. And I can divide by a B, B there, one of those two B's, and one of those. So you get left with 3A plus 5B over 7B squared. Now, as you can see from the PDF, there's more to come, but we're going to pause there because we're all a bit tired in class. So we're going to put our feet up for a bit. And on Monday, we will go through the next thrilling instalment. I will see you then. GoPro, stop recording. GoPro, stop recording.